Okay guys, okay, so in this video let's talk about some algorithms in linked list. Okay, some basic algorithms which I wanted to give you. Okay, so we have created a linked list, right? We have seen how to create a linked list using C program. We have used the concept of structures, pointers and memory allocation. I hope you're clear about that. If you still have any doubts, please post those questions in the Q&A section. Okay, so that I'll be able to help you. Okay, so in this video let's talk about inserting and deleting. Okay, insertion and deletion in linked list. Okay, and you have different types in this. Okay, as far as insertion is concerned, you have three different types of insertion. One is inserting at beginning, inserting at end, and inserting at after a specific node. Inserting means inserting a new node, guys. That's it. Okay, after a specific node, okay, specific node. And deletion, same. We can delete the first element, so deletion at beginning, that is, and delete the last element, deletion at end, and after a specific element or specific node. So totally you have 6 algorithms. Okay, 1 2 3 4 6 4 5 6 algorithms. Okay, totally you have 6 algorithms as far as the insertion deletion operations are concerned, and I'll explain one by one. I'll first of all I'll give you the idea of how I'm gonna do, and after that I'll implement that using C programming. Okay, so for all the examples I'm gonna consider this linked list only. Okay, I'm gonna have this linked list only. Okay, so I'll be having 10 here. Okay, and I'll have one more node, and let me have one more node. Okay, and what is the address value? Address value should also be assumed. I'll assume this as 1001, this is 1002, and this is 1003. Okay, address value will not be will not be consecutive, or will not be in a sequential order. Okay, it will be randomly allocated, but let me assume it as 1001, 1002 and 1003. Okay, then what is the value of this? This points to the second node, right? It's like, what is the address of second node? 1002. Okay, and so this will have the value 1002. Okay, and this will have the value 1003, and this will have null because that is the last node of your linked list. Okay, and first of all you need an external pointer called as start. Okay, and that will point to the first node, right? And what is the value of start? If somebody asks you what is the value of start, start will have a value 1001 because it points to the first node, and you don't have data next to separation here. Start is nothing but an external pointer which points to the first node. All right, so for all the algorithms I'm gonna use only this example. Okay, so please make a note of this example. Okay, so I'm gonna use only this example, this same values and same address value, so that you will be finding it very easy. Okay, so I have 3 nodes, and I'll be having one external pointer. All right, so we have seen how to create this linked list and how to print that in the previous video, right? So let me continue with that. I hope you understood that, and let me continue with that. Okay, so yeah, you have an external pointer here, 1001 say, and it is connected to, or let me ignore that external pointer because I should have some space. The first algorithm is insertion at beginning, right? So insert at beginning, or the first node should be your new node, right? So how to do that? First of all, let me have the linked list 10 1002, and points to the same example, guys. I told you 1003, this value is 1002 actually, and it points to 30 null, and this is 1003. Let's say I want to, and this is 1001, guys, and my start variable will also have the value 1001. Okay, I'll just encircle it to ensure that this start points to this first element. Okay, let's say my new node is this. I'll have 40 and null. Okay, this is my new node. Okay, let's say this address is 5001. So because you have to create a new node also, and that will also have an address 5001. Okay, what I'm gonna do here is very simple. Insert at beginning, right? Insert a new node at beginning. Insert at beginning. All right, so how do you insert at beginning? It's very simple, guys. Observe that this is your first node. Okay, this is your first node, and you also have a start. Let us have that also. You also have the start pointer points to the first node, right? So what you have to do here is, so this is your overall linked list and this is your new node, right? So what you have to do here is, you just have to okay, I'll just draw this neatly so that you will be able to understand it more clearly. Start pointer, which will have the value 1001, guys. It will point to or else inside a start, I'll just have 1001. Okay, it will point to the first node. All right, so what I am gonna do here is, observe this link, guys. Okay, this link I'm gonna cut it. I'm gonna cut this link. I'm gonna just cut this link, and I'll make this one points to I'll just make the start points to this 5001, the new node, because I just want to insert at the first element itself, insert in the beginning itself. So this I'll make this points to the new node. Now it will have a value 5001, and the next field of this particular new node will point to the exact first node. Alright, so the idea here is, I'll again repeat the idea. Initially it is pointing to the first node, but we are doing insert at beginning here. You just want to insert the node at the beginning. Okay, you want this new node to be your first node. That's it. You want this new node to be your first node. To do that, what you have to do, you just break the link and make it point to the new node. Make the start variable point to the new node, and make this new node point to the this particular element. So now this becomes the first node, this is second node, this is third node, this is fourth node, because our start points to this node only. This is called as insertion at beginning, guys. Okay, so we're gonna perform this. It's very, very simple. Okay, how do you make start points to this node, guys? Let's say this is new node. How do you make that? It's pretty simple, right? You have to say start equals to new node. All right, so this statement, it's must in the very crucial statement in case of this algorithm. Of course there are some other important statements also, but this is very crucial. Okay, and the next change that you have to make is, new node of next, new node arrow next should point to this node, guys. Okay, this node is what, this node may be initially you can say that's the start node, right? Yeah, you can name this node and you can put that here. Okay, new node of next will point to this second node. Okay, so that's the idea here, guys. I hope I made it clear. So okay, guys, let's move on and perform the basic insertion and deletion operations, guys. So insertion is inserting something at the beginning, and node, I mean the end node, and after a specific position, right? So we have seen the algorithm, how it works to insert something at the beginning. Okay, let's implement that using C program in this video. Okay, so let me create a new file. I hope I have to do that, and I'll say main1.c. okay, so I'll just start fresh. Okay, if I want, I'll just copy the code, some code. Okay, like the structure of node and all. I can just copy. I need not type it again and waste the time, right? All right. So hash include std.h and stdlib.h to for dynamic memory allocation. Then I'll copy the struct node code. This is our code. This is the code that we have written to create a linked list. Okay, we can use the same code to create a linked list. I hope. Yeah, we can just copy this, because anyway we have to create a linked list. Okay, so for that purpose I'm just copying this. Okay, so I'm just creating void main is missing. So after that I'll perform insertion at the beginning. Okay, so yeah, so I think it's okay. So I'll perform insertion. Okay, so here after getting all the list elements, here I could say printf enter the element which you wish to enter the value which you wish to enter at the beginning. Okay, you know the algorithm. Okay, assume that our list is created, our 10, 20, 30 example is already created. Okay, and here is just to display. Okay, I'll do one thing. I'll leave this. Okay, just to display. I hope it is not confusing you. I'll say comment display. Okay, all right. So enter the value which user wants to enter. Okay, let me scanf and store it to somewhere. Let me use the temp variable itself. We have already declared that, right, in the previous videos. Temp variable, okay, that is a temporary variable which I have used, so let me use that itself. Okay, let me create a new node. That's very important. Okay, let me create a new node. So how to create a new node? It's again very simple. New node, malloc size of struct node, and here I will be having another struct node. I mean, I'm typecasting it. You know this idea. You know the syntax, right? So let me move on quickly. So new node of data field, you should have the value that we got. Okay. So this new node should be inserted at the beginning. Okay. Understand that this new node should be inserted at the beginning. How I'm going to do that? That's again, that's a very simple one. Let me cut this and put that here. I mean, so all right, I think now our weapons are ready, our elements are ready, our new node is ready to be inserted at the first, and my start is ready. I have created a copy of start, so temp1 will be pointing to the first element, like first node, and start will also point to the first node, but I won't manipulate start. Okay, okay, of course here I'm going to do that, but you know, in most of the times I'm not going to manipulate start. Okay, super. So insertion. Okay, so you know the idea, right? So if you don't know the idea, please go back and watch the video again, which I have explained your algorithm, right? So new node is there. New node of next field should point to start arrow next. New node arrow next should point to start arrow next. What do you mean by start arrow next? Which means it's not start arrow next, I hope. I think it is start itself, because I just want to insert it at the beginning, right? So it's actually start. So what is new node of next is start. New node of next is nothing but the next field, you know that, and that will have the value start. What I mean by is this will point to the first element. New node will point to the first element. What do you mean by that? New node will point to the first element, which means that new node is gonna become the first element. Okay, so here it is gonna become the first element. Okay, it is pointing to the first element. Okay, the previous first element. I mean, you ignore this code, then there is some first element, right? And that is given by start variable, start pointer, right? So you are making your new node to point to that particular first node. So it's gonna become the first element. I think that's it. Okay, you have to make start also to point to new node, because here I have made new node as the first element. So make start point to new node. And again, I think you can get the code and manipulate it here. Okay, so this set of code is something inserting at the beginning. Okay, I think this is clear. So what I'm doing here is I'm just creating a new node, getting the value from the user, maybe 40 or 50. I'm storing that in data, and the new node of next field should point to the first element. Okay, then it will become the first element. Anything which points to first will become the first. Okay, will become the first now. Okay, so new node now will become the first element. After that, you will make the start point to the new node. uh, to make it clear, let's assume some values. Okay, let's assume our start equals to 1001. Okay, our previous start. Okay, our previous start equal to 1001. You know that, right? Okay, what is the address of new node? I don't know, maybe 5001. Okay, maybe 5001. Start is maybe 1001, and it's not next. Start is maybe 1001, and new node is 5001. And new node of next field should point to start, which means that new node of the next field will have the value 1001. So now start points to new node, which becomes start will now become 5001. So now this becomes the first element, and the next field of first element points to 1001, the old first element. Okay, I hope I made it clear. If you have any doubts, you can post it in Q&A, or you can also watch the previous video again. There I have explained this very clearly, right? That's it, I hope. Let's run this code. Oh, hold on, new node. Yeah, we have declared new node inside the for loop, so that will not work, right? Let me do that outside the for loop also. Okay, so let me do that here. All right. Hold on. I think it's visible. Let's run the code again. Multiple definition of main, of course. I'll just close the whole program. The old program, I need to close this. So what I'm gonna do is I just copy this. Yes, it will work now. Yeah, enter the number of nodes. I have 3 nodes. 10, 20 and 30 are my node values. Okay, enter the value which I wish to enter at the beginning. Okay, in the beginning I just want to have 40 in the beginning. So the elements are 40, 10, 20 and the last element is not getting printed, I hope. So let's correct it now. Okay, I think I just have to copy the print statement and paste it here. Let me do that again. Okay, so 3, 10, 20, 30 and the element I wish to enter at the beginning is 40. So you can see 10, 20, 30 are my list elements, the exact values, but 40 is now the first element. So by just doing these two simple lines, actually these two lines are the crucial or core of this algorithm. Okay, if you know how to do that, then it's very simple. Okay, so please understand this, and if you have any doubts, please post that in the Q&A section. Thanks a lot.